So again, looking at the first part of the notes, the first part of the notes is really just a big review of a lot of stuff we've talked about. So looking at just kind of the first four parent functions, linear, quadratic, and cubic. Whenever I'm talking about the degree, again, I'm talking about the largest exponent. Okay? So what is the degree of this function right here? 1. What is the degree of a quadratic? Cubic? 3. Alright. Looking at your end behavior. So for linear, as x approaches negative infinity, what does y approach? Negative infinity. As x approaches positive infinity, what does y approach? Positive infinity. Is that also going to be true for a cubic function? Yes. Is that going to be true for any positive odd function? Yes. So what I have written, and what you should have written underneath linear, you can write that exact same thing underneath cubic. Okay? Let's go ahead and do quadratic real quick, and I'll give you some time to get all of it written down. On quadratic, as x approaches negative infinity, what does y approach? Positive infinity. As x approaches positive infinity, what does y approach? Positive infinity. It is up, up. So both of them are going up. So looking at the degree, I want to write a couple things down on this. Again, your degree, it is the largest exponent. Okay, and that is if it is in standard form. If it is in factored form, and we're going to see this a lot more today, how you find the degree of the entire function. Okay, so the function's degree is the sum of all the factors' degrees. This may not make sense until we go through an example. Okay, but whenever we get to the back and we see that, I'll refer back to this, and I'll kind of point out exactly what it is I'm talking about. Okay, looking at this and filling this out. Again, we already had linear, which was a positive odd degree, and so was cubic. So that right there, that is the same that you have underneath linear and the same that you have underneath quadratic. That you have underneath cubic. And if you remember the little cloud things that we've written, I started writing it a little differently. And I think if you remember this, memorize these 4 little clouds and what goes inside of them, by the time you get the test next class, I would write it right whenever you get the test. Okay? And all I've just kind of been adding something to it. So if I have a positive odd, then it is a down, up. And that's all I've been putting. That O stands for odd. If I have a negative odd, then it is up, down. If I have a positive even, it is up, up. And then if I have a negative even, it is down, down. Okay, so you can go through there, make sure that you have all of the end behaviors correct. Okay, so if this is up down, then it's that one is infinity. My down is negative infinity. Still having some people that I think are kind of confused on this in behavior stuff. On a positive even, okay, it's up, up. So both my y's are going to positive infinity. And then if it is a down, down, both my y's are going down. So they are both going to negative infinity. So where it says multiplicity down there, I'm going to talk about that you can also look at that as the degree of the factors. Okay, in fact, most of the time that's what I refer to it as. You don't have to write this next part down, but if in your equation you have this, okay, that x plus 2 factor has a multiplicity of 2, or it's happening twice in that equation. Alright, so if you had that and you're asked to write it in standard form, which you've been asked to do that before, you would just expand it out. Okay, if that was to the power of 3, it has a multiplicity of 3. It's occurring 3 times within the function, and you would write, if you had to write in standard form, you would write x plus 2 3 times and then multiply that out. Okay, so whenever you see multiplicity, especially on the review, this one's multiplicity is 3. If it didn't have anything written up there, its multiplicity would be 1. Okay, that's all it's asking for. And we'll see some examples on the back. But normally what I will refer to that multiplicity as, again, is the factor's degree. Alright, and so we're going to graph these things from the factored form, and depending on what each factor's degree is, what we're focused on is how it crosses the x-axis. Okay, and so kind of follow me, especially through the first example, until you kind of have questions. It may not make sense till we get through that first example. So if that factor has a power of 1, we are going to say that it crosses through. Okay, you with me, Jessica? Okay, that it's just going to cross through the x-axis. Alright, an example of that may be x plus 7. Okay, it's got a degree of 1. There's no exponent up there. What that's going to look like on the x-axis, let's say there's my point of negative 7, 0, because that's the x-intercept it's going to give me. The graph is just going to cross right through that point. Okay? If you have an even power, we're going to call this a bounce. Sometimes you've heard me refer to as it just go down and it just touches the x-axis. Think about a parabola. And, it's just going to do that bounce. That vertex is going to be right on the x-axis. An example of that, it could still be x plus 7, but now it's squared. So that x-intercept would be occurring at the same spot that the first one would. It would still be at negative 7, 0. The only difference, instead of crossing through it, it would just bounce. Looks like it bounces off the x-axis. Next, if you have an odd power greater than 1, we're going to call this root behavior a twist. And kind of think of how a cubic graph looks like. Okay, so an example of this, x plus 7 cubed. Still going to be occurring at negative 7. The only difference is it's going to go up. It's going to look like it's about to bounce off of it, but then it curves and keeps going up. Okay, so just like a cubic graph. So that's what we're going to call a twist. Now, so your three rules, you need to know your three rules. One rule is the degree 1, is the degree an even number, or is the degree an odd number greater than 1? So those are your three rules.
What if it's 4?
So let's go over to the back. We're going to go through 4 or 5 of these examples, and then that's today's notes. Okay, so first we need to identify where the roots are. One thing that's going to help us out, and you may kind of write it at the very top, is I'm going to go ahead and write all these out that give me my end behavior. Also, an easy way just to kind of remember it, if your two arrows are going in the same direction, if they're both going up or they're both going down, it's even. Okay? If they're going in opposite directions, they're odd. So, let's come over here. So dog it, just that x plus 2. What x-intercept is that going to give us?
-2.
Okay. Max, x minus 1 is going to give us what?
+1.
1. Jake, x minus 3? Okay. So next, we need to find the degree of the whole function. So this is where, on the front, where we talked about how to find it from factored form. I'm going to add up. It's going to be the sum of the degrees of each factor. I'm just going to add up all the degrees. So this first factor right here, Connor, the x plus 2, what is the degree of that factor? Do what? 1. Alright. Garrett, what's the degree of the second one?
2.
What is that right there? What's understood to be in that spot?
0.
No. 1. Okay. Gabby, what about the third degree? Or third factor? What is the degree of that factor right there? 1. So, what is the degree of the whole function? 3. It is the sum, so I'm adding up all of those degrees. So the degree is 3. The function is positive. Alright, that's just as simple as looking at the very beginning of the equation. There's not a negative there. So if this is a positive odd, Mr. Carter, what is my end behavior going to be? Is it going to just say up, up, down, whatever? If it is a positive odd.
So it's going to be a down, up.
Down, up.
How did you know it was going to be odd?
3 is an odd number. Alright, so going through and writing what my root behaviors are. So this is the bounce, cross, twist, all that stuff. All of these have a degree of 1. So they are all going to be what? What do we say on the very front? They're all going to just cross. Okay, so I'm just going to put a C underneath them. So they're going to be C, B, or T. So next, I'll go over to the graph. Obviously, since it's not labeled, very roughly, I'm going to put where -2 is, 1, and 3 would be. I need to know my end behavior because I need to know where to start. Whether I need to start down and go up, or start up here and go down. Okay, so since it's down, up, I'll start at the bottom. And since each one of these, it just crosses through.
I know how high I'm going.
Okay. If you didn't hear Max said how high or low does it need to go? All I'm worried about right now is that you can identify where the graph crosses the x-axis and what that root behavior is. And by root behavior, I mean cross, bounce, or twist. how high and how low you make your extremas, or even where you put your x-intercept, I do not care for the sake of today's lesson. Questions on that first problem?
How do you know it was positive?
There was no negative at the beginning. There'll be a negative at the very beginning of the equation. So if you look at, I think, the last two, those both have negatives at the very beginning. So that tells you it's negative. So let's look at number 2. Ashlyn, what would my roots be?
X equals -2, x equals +2, and x equals -6.
Fabulous. Alberto, what is the degree of just that first factor, the x plus 2?
1.
1. Sam, what is the degree of the second factor?
2.
2. Max, what is the degree of the third factor? 1. So, Garrett Carter, what is the degree of the whole function?
4.
4. So it's 4. It is a positive function. Okay. Sam asked me just a minute ago, how can I tell if it's negative or positive? Again, if there's just not a negative at the beginning. Examples 4 and 5, those have negatives at the beginning. That's all it is. Don't overthink something like that. This is even. 4 is an even number. So if it is a positive even, Mia, what would the end behavior be?
Up.
Pardon?
Up.
Up, up. Okay. Up it is. And so now I'm going to take these roots, put them down there where it has the root behavior. And x minus 2 had a degree of 1. So Cambridge, is that going to cross, bounce, or twist? Cross. Gabby, x equals 2. That had a degree of 2. So is that going to cross, bounce, or twist? Bounce. Amelia, x equals -6. That one had a degree of 1. So that is going to do what? Cross. So I've got my x-intercepts at -6, -2, and +2.
I know where that doesn't go in the right order.
Yes. If you would rather write, whenever you do your root behavior, write it in ascending order, so -6, -2, 2, that's perfectly fine. Because if I graph this, I'm going to graph this one first, then the -2, then the 2. So I've got to be careful when I graph it. So it's an up, up. So I'm going to start up here. At -6, I'm going to cross. At -2, I'm going to cross. And at +2, I'm going to bounce. So cross, cross, bounce. Going to number 3. Mr. Carter. What are my roots on number 3?
X equals -2. X equals -5. X equals 3.
Awesome. Doggy, what is the degree of that first factor?
1.
Jessica, what is the degree of the second factor?
3.
Kevin, what is the degree of the third factor?
2.
2. So Cambridge, what is the degree of the whole function?
5.
Hmm?
6.
6. 6. There's no negative at the beginning, so it's positive. So I've got a positive, even. So Sam, what is my end behavior?
When x is approaching negative.
So is it?
infinity.
So just tell me up, up, down, down. Up, up, or down, down.
Oh, okay.
So if it's positive, would it be up, up, or down, down?
Up,
Up, up. So Max, the x equals negative 2. What is the root behavior at that x-intercept?
Cross, and then the next one would be twist,
Yep.
and then bounce.
Awesome. So I've got negative 5, negative 2, and positive 3.
How do you twist that? Like, what do you...
I'll show you. And it is up, up, so I'm going to cross. So again, make it look like you're about to bounce, but then just curve it and go down. So twist at negative 5, cross at negative 2, bounce at 3. Looking at number 4. Amelia, what would the roots be?
Negative 2, negative 1, and positive 1.
Okay. Jake, what would the degree of the whole function be?
5.
And is it positive or negative? Okay. So, Colton, if I have a negative odd degree, what's my end behavior going to be?
Up, down.
Up, down. So my degree of negative 2, Jessica, is that going to cross, bounce, or twist?
Cross.
Cross. Amelia, negative 1, is that going to cross, bounce, or twist?
Twist.
And Massey, x equals 1, is that going to cross, bounce, or twist? Cross. So I've got, now we'll just spread these out a little bit. Negative 2, negative 1, 1. It is up, down. And I'm going to cross, twist, cross. Once you have that written down, if you don't have any questions, I want you to attempt number 5. That's what you should have gotten on the last problem.